Hello there, welcome class to Professor Roldan's review for Chapter 8, Hypothesis Testing in the Introduction to Probability and Statistics. I sent this review out previously, and this is just for if you just want to hear kind of where I got some of this stuff from. I don't really have time to work it out in front of you, so I'm just gonna refer to it and point to it as we move along. So I hope this is helpful to you, and I plan to do some more in the upcoming sections and for the final exam. So let's get started here. So these questions come from the textbook in each section, in the homework section. And basically I am picking some problems that are similar to test questions. And in this review, I'm only going to be using StatCrunch, okay? I know there are some big formulas, especially in table 8.2 that I won't be using, okay? That's for the manual calculations, and really, if you're going to be a math major, those are some good things to kind of work through if you're going to study statistics in the graduate level or whatnot. But for the most part, the vast majority of people just use technology, okay? Okay, and you also have to forgive me for my sniffles here. I have allergies, and it's been bothering me lately. So just trying to get through the day with the stuffy nose, but I'll be fine. So excuse that part of the video. And we're going to go ahead and get started. I'm going to run through this quickly. I'm going to be referring to whatever I've written. I'm not going to read everything. I'm just going to kind of go through some of the highlights, okay? And try to get through this as quickly as possible. You're welcome to pause and backtrack and review it again if you need to. So starting with sections 8.1, it has a really good question about p-value, because when you're looking at p-value, you're never really going to see large p-values, okay? Because we're talking about the tail of our graph. So usually it's going to be one of these or some variety of a small tail, okay? Some tails are larger, but if you see this number for p-value, something's not right, okay? Now, the best p-value in getting strong statistical evidence that supports H1 or the alternative hypothesis would definitely be the smallest, okay? Definitely be the smallest, because you're going very far away from, you're getting very far away from the average or the middle. So a p-value very tiny means that you're way out here, which basically disproves HO. HO's in the middle. That's the majority of whatever's going on. And so you're trying to prove that it's not the majority, so anything tiny is the best, okay? Now, number 2 has... I'm sorry, not number 2. Number 7. So the next one just talks about, how do you write a claim? How do you symbolize a claim? And how do you symbolize the opposite? And then what's the null hypothesis and alternative hypothesis? So you just have to read and see what the claim is, okay? And so there's the claim. Now that indicates whatever's coming out. Next is what you're going to write down. Okay, so I have that here. That's the claim, that it's equal to 69, the mean pulse rate for adult males. And so the opposite is going to be not equal to. All right. Now, when the rest of this review, okay, equality, anytime you have equality, that's going to be the null hypothesis, HO. And sometimes you get it at the top, but I just write it in order. I don't really like to switch things around. So this happened to be nice and neat in order. So the opposite of equals is not equal to, and that's my alternative hypothesis, which happens to be a two-tailed test. Okay, what I mean by that, I'm talking about, okay, so if it's not equal to, it could be less than or it could be greater than. So there's a kind of two areas that we got to check for, okay? And so that's what I mean by two-tailed test, okay? If we can prove that it's either here or it's here, then we can reject the null hypothesis, okay? So I'll be referring to what type of tail that we're going to be dealing with in the rest of this review. Next, we have number 15, which talks about basically referring back to number 7. And so we have the given information. I wrote it down here. Okay, so these are the number of observations. This is the average pulse rate. This is the standard deviation for the sample. And then the claim is that the population mean is 69. Okay, so you have two different means. You have the sample mean and you have the claim, which always refers to a population test statistic. Okay, so this is it's a different symbol. This is claiming for the population of males is 69. This is the sample, and so now if you check it here, there you have the sample mean and the population mean. Okay, well, you also have it here and here, but this is the variance. I'm sorry, not the variance, but the population standard deviation. We don't have that. We have a sample standard deviation, S. So there's my S, and that's why I chose T, okay, for the sampling distribution. All right. Now, how do we calculate what T is? Like I said, you can do the formula if you want. I'm not going to do that, but StatCrunch, here are the steps. You just make sure you open StatCrunch in your from MyFire. In the My Resources page, and you'll get, once you open it, you go to Stats, T-Stats, one sample with summary. Why with summary? Because we have the summary statistics right here that you're going to enter in. So whatever data it asks you for, you type it in correctly, and then you hit compute, and it gives you this T. Okay. All right, we're going to continue here with the other column, and we have p-values once again, which is good stuff here. And then A, B, and C has identified the hypothesis test as being two-tailed, left tail to right tail, find the p-value, and then use alpha is 0.05. Do you reject or fail to reject the null hypothesis? So let's look at number 17. And so we have a z statistic of 1, and the claim is the proportion is greater than 0.3. So that's the claim, and that is greater than, so it's right-tailed, it's on the right side. And so the opposite of that, we're always going to put equality for HO, okay? Or the null hypothesis. So I used the table to figure out Z. I looked for 1, and I did 0.00, and then in the table it gave me a probability of 0.8413. But I do have to subtract, because that right there that's actually giving me this entire area. So the reason why it's a big decimal is because it's giving me all of that, and I'm actually looking for this part right here. So I have to subtract 1 from that to get the 0.1587. Okay, so this right here is 0.1587, and alpha is 0.05. So because it's greater than, we fail to reject. Okay, always reject HO if the p-value is less than alpha. Since it's not less than, it's actually greater than, then we fail to reject. Okay. Now, if you don't want to don't want to use the table and then subtract by 1, you can simply put this information in your stat calculator on the normal distribution with a mean of 0, standard deviation of 1. But this is 1. Make sure you change this to greater than or equal to. Click compute, and it will give you a probability of 0.1587. Okay, so same thing we do for number 18, which is just a different number. It's a number on the left side. So because this is a number on the left side, it's on the left side, so it's actually the number in the table is actually going to give us this. That's what we want, and so we don't have to subtract 1 in this case. So if you look at the table, it gives you 0.0062, and that is actually the p-value, okay, because it's the left tail. All right. Now, since 0.0062 is less than 0.05, we reject HO, okay? And that is it for this page. This is page 1. We have 3 more pages to go. Let's go on to the next question. Okay, so 8.1 continued. Again, a reminder, if the p-value is really small and it's smaller than alpha, we're going to reject the null hypothesis, okay, which means that it's very far away from that mean, from the middle part. And we also have 2 parts: state the conclusion, and then, without using technical terms or symbols, state a final conclusion. So number 25, we have a claim here that the proportion of adult males, 58% of adult males would erase all their personal information online. That is a right tail test, and the opposite of that is equal to. Okay, so null hypothesis is always equality. And then it gives us the p-value right here. And so we have, this is obviously large, much greater than 0.05, so we definitely failed to reject HO. That means that there is not sufficient evidence to support this claim. The claim is that the proportion is greater than 58%. Okay, so that's definitely not the case. There's not enough evidence to basically to get out of the status quo here. The status quo says yes, that's 58%. It's definitely not more than, it's just 58%. Or less. So there is not sufficient evidence. And this type of wording, I put a note at the bottom here. On page 366, you'll find the wording for the 4 different conclusions, okay? All right, so the next one, we have a claim that the proportion is less than 90%. And so opposite would be that it's equal to 90%. And that's less than, so it's a left tail. The p-value given was 0.003, really, really small, way smaller than 0.05, so we reject the null hypothesis, okay? So that means that this is really, really far away. It's in the tail, in the rejection region. So basically, the conclusion is there is sufficient evidence to support the claim. Now, you need to go ahead and fill in the context. So this claim is that the mean pulse rate in beats per minute of adult males is 72 beats per minute. So I'm not going to be filling in the context. I'm just going to write the particular part that you need. The rest you just copy from the original question, okay? So there is sufficient evidence to support this claim right here, okay? It's not status quo. That's what this is, okay? This is far from status quo or from the middle. Number 27. So this time, the claim is equality. Okay, if you go back. So the claim is 72 beats per minute. So this doesn't happen a lot, but sometimes we have the claim as being the null hypothesis because it's equality. Okay, so is right there. The claim is basically status quo. Okay, and it's not less than or greater than, it's just equal to this. And so that's our equality. The opposite would be not equal to that. Okay, it could be smaller, it could be greater. That's what we're going to be testing. We're going to be testing two tails to see how far away from the mean it is. And in this case, we have a really small p-value. That means it is way out there in the tail, okay? And smaller than the alpha, so we're going to reject HO, okay? We're going to reject that it's equal to 72. There is sufficient evidence to warrant rejection of that claim. So this claim right here, we have enough statistical evidence to say, nope, it's not equal to, it's actually not equal to, or further away from 72. Okay, so again, don't forget to look at this page look for wording, and we'll use that wording throughout the review. Okay, so 8.2, we're going to do two steps. Again, I'm not going to use the math that is in the textbook nor in the help. I'm just going to be using StatCrunch. Okay, when it says using technology, that's what we're going to use. Okay, you're welcome to use graphing calculator or some other technology, but this is what we're going to be using. So we're going to do that, and then we're going to basically say if it's really small enough that it's smaller than the alpha, we're going to reject HO. So it's a good idea to write down the given information. In this case, we had in favor of the pole, opposed to the pole, so that gave us a total because they didn't give us a total here, so we had to come up with this ourselves. Okay, and we're going to need this for StatCrunch. Okay. Now the claim right here is that the proportion is equal to, okay? So that's going to be, this claim happens to be the null hypothesis because it's equality. Okay, the opposite would be not equal to. It's a two-tailed test. In StatCrunch, you basically go to stats, proportion stats, okay, because this is 8.2, it's talking about proportions, and you have a portion of the total, that's a proportion, okay? So proportion stats, one sample with summary. Why with summary? Because we have the information we need. We have the in favor, we have the total, and that's all. That's basically what we need here. So enter data. Once you pop it up, it's gonna ask you for success, 481. Total observations, 882. You make sure your HO is equal to 0.05, and then you have the not equal to. This is what you have to choose. Okay, between less than and greater than and this, you're going to choose this one because it's a two-tail test. And then click compute. It gives you 0.007. That's definitely smaller than, well, it's smaller, but it's not that much smaller than 0.01. But we still reject HO. Okay, which means that there is sufficient evidence to reject this claim right here. Okay, that it's equal to that. Okay, and that's really the power of statistics. This politician is claiming, okay, that people don't understand the stem cell issue. It's basically, hey, flip a coin. That's how you're gonna get responses, and so the politician's claim is wrong. Okay, so this is a cool example where you can see, the power of statistics affecting truth. Okay, it's this person is claiming this is truth, and we use science or math to disprove that claim. Okay, which is very important for your next statistics course for psychology or business or whatever field you're going to, because a lot of people are going to claim stuff and you have to understand the numbers so you don't get easily deceived. Okay, we're going to use science and particularly mathematical statistics to test whether something is true or false, especially in business or people claiming things and then they want to sell it to you with that claim. And so here we have 3 observations. We have 27 successes. We have an alpha of 0.05, which is pretty standard. The claim is that less than 10% of test results are wrong. Okay, that's a company basically trying to protect itself there, saying that it's pretty small. So that's the claim. Okay, hey, we mess up this, less than 10%. Opposite is equality. Now we enter all this in StatCrunch, we get a p-value of 0.2819. That's kind of big. This is actually bigger than 0.05. So then we fail to reject HO. Okay, we don't have enough evidence to support this claim. So HO is equality right here, and so we don't have enough evidence to support the company's claim. Okay, or they don't have enough evidence to support their claim. Okay, using statistics. Okay, the next one. Super Bowl wins. Okay, first 49 Super Bowls, 28 of them were won by the NFC. Okay, that kind of looks like half. So the claim is that NFC Super Bowl winners are more than the other league. I can't remember. I think it's AFC. Okay. So we're going to test that claim. It looks kind of clear that it's half and not more than half, but let's test it out. So we have 49 observations, 28 successes. Alpha is 0.05. Our claim is that it's greater than. That's obviously in bias or in favor of NFC. We're going to say, nope, status quo, that's the opposite of this. It's actually half. Okay, so half goes to NFC, the other half goes to AFC. And so StatCrunch produces a p-value of 0.2031. And this is large, definitely greater than 0.05, so we failed to reject the null hypothesis, okay? That we cannot accept this claim right here. We do not reject this. There's not sufficient evidence to support this claim. There's not enough mathematical evidence or statistical evidence to support this claim. We have to basically go back to status quo, okay? Okay, halfway done. We're on page 3 here, 8.3. Sorry that I'm going kind of fast. But you can always pause it and rewind it. Just kind of going over my answers here. So 8.3, we're going to be testing out means, okay? Sample means and population means. So first of all, degrees of freedom. What is it? Basically DF. You're going to need this for some of the StatCrunch calculations. And if you're using the math formulas, you need that as well. But basically, it's a sample size minus 1. That's what DF stands for. So if the sample size is 12, you just subtract 1 from it, and the degrees of freedom is 11. Okay? So here's a claim that Verizon data speeds at airports, the mean is 14 megabits per second. Okay, so Verizon obviously wants this number to be high because that will attract more customers if their speed is high, okay, at the airport. So the sample size is 13. It's kind of small. Test statistics, they went ahead and calculated a T for us. So so the claim is, hey, this is our speed, okay? That's and it's equal to that. So that's going to be the null hypothesis because it has equality. The opposite is, you know what, Verizon, it's not actually, it could be slower, it could be faster. Most likely it's going to be slower, but we will see. Okay, there's a test statistic. Now, StatCrunch, to get the p-value, we're going to use our stat calculator. Okay, you're going to choose T, and you're going to choose between because this is a two-tailed test. And so it's going to give you the probability between these 2 points. It's going to give you all of this. So it's going to be kind of a high number, like 0.8699. So it's going to ask you for degrees of freedom, which you're going to put 12. Subtract 1 and get 12. They gave us T is negative 1.625. That means you put this for the left side. That's this left number. The positive version is on the other side. Remember, this is symmetrical. This is a bell curve, so it's symmetrical. And so then the number it gives you is the middle, and we're not looking for that. We're looking actually for the tail, okay? And so if you do, remember, this whole thing is 1. You subtract this big middle part out, you're going to get the leftover. So that is, in this case, 0.1301. Okay, so I hope that helps clarify some stuff. We're not going to do number 6. We're going to move on to the next question. And so we have this already done for us, which is awesome. Okay, we have the StatCrunch information right here. And so we just kind of look at the results. Okay. So someone here is claiming that the mean tornado length is greater than 2.5 miles. And as you can see, there's the claim right there. And so let's put claim, and this is status quo or basically equality, okay? Now, p-value is 0.2242, and since that is a big number compared to 0.05, and it's greater, we're going to fail to reject HO. There's not sufficient evidence. There is not sufficient evidence to support the claim that, what claim? That the mean tornado length is greater than 2.5 miles, okay? So, sorry, not, sounds great, but it's just not enough evidence to support that claim. It's either equal to 2.5 or it could be less than as well. Okay. Let's go to the next question, number 13 and 8.3. Okay, so in this case, we have a data set, and they give us all the summary statistics, and which is nice. Now, I went ahead and rewrote everything here as our given information, including alpha. The claim, which is right there, is the mean is equal to 4. So if that's equality, that's our null hypothesis. And that means the opposite would be the not equal to. That's a two-tailed test. Now, put everything in StatCrunch, enter the data, compute, and we get, if they ask you for a t-statistic, that is there for you, okay? If they ask you for p-value, that is also there for you, okay? And so it is much easier to use p-value because we just compare this to what's given. We don't have to calculate what the t-statistic is, or the critical value for t. We just don't really need this. We just need this compared to that, and we are good to go. Since it is greater than 0.05, we fail to reject HO, which means there's not sufficient evidence to warrant rejection of the claim. Okay, so we fail to reject this claim. There's not enough evidence to warrant rejecting it. Okay. Next, number 23, car booster seats. We have some data this time, okay? So that means they're not going to give us the summary statistics, but thank goodness for StatCrunch, okay? Now, let's go ahead and pay attention to the alpha, which is very, very small, which means they are getting very strict on the test, okay? So that means that the p-value has to be really, really small in order for us to reject HO. The claim is that the sample is from a population with mean less than 1,000 IHC. So that is right here. There's the claim, less than. Opposite is equal to. Equal to is always, or equality is always the null hypothesis. Alternative is always what we're testing. In this case, StatCrunch. Now, in my math lab, it has a little, it's like a little symbol here somewhere. If you click on that, it'll give you the option to open in StatCrunch. So open this in StatCrunch is the easiest. If you don't click that, or if it's not available, then you would have to open a blank page in StatCrunch, and then you have to type it in. Okay. So once you type those 6 data points in the first column, then you use that basically to say, okay, I wanted to calculate my t-stats, one sample with data. Okay, so this is the new part. So you're going to do with data. So now This is probably going to be in the first column. You just kind of click it, make sure it goes to the part where it's going to actually look at this column for calculation purposes. Click compute, and then it gives you the t-statistic and the p-value. And the p-value is really all we need. And as we can see, even though this is a nice small p-value, it's not small enough for this particular test. Okay? So in this case, because the testers were very strict, and then they should be strict because this is child safety we're talking about here. Okay? Child safety is very, very important, so this is a very strict test. Okay? And this is not good enough. It would have passed if we would have used 0.05, but it didn't. So we failed to reject HO. Okay. We failed to reject HO, and so there's not sufficient evidence to support this claim right here. Okay. Now guys, I'm going through this pretty fast, so you can always stop it and look at it again or listen to it again. But you can always email me and tell me what page you're on and say, hey, I have a question about this particular thing that you're discussing. Could you explain that more in detail? I'll be happy to help you with that. Okay, guys? So last section is 8.4. This is page 4 of our review. Now, you got to read the paragraph and take out all the key information. We have total observations. We have our standard deviation. We have the range rule of thumb. Gives us something close to that. And basically we're going to test the claim that it's equal to 10 beats per second. So notice that the claim is right there. It's equal to. Put this all in StatCrunch. Actually, it did it for us already, which is awesome. Now we just look at the p-value, which is 0.0208, which is smaller than 0.05. So we reject the null hypothesis, which in this case is the claim. Okay, so that means we're going to say there is sufficient evidence to warrant a rejection of the claim. Okay. All right, last question is number 11 from the textbook. And again, get all the key information that you need, which I write down. I would recommend you write down. So 27 observations, our sample mean, our sample standard deviation, and our alpha, okay, which is basically how strict are we going to test, okay? 5% is standard, okay? So the claim is right here. The claim is that the coffee vending machine dispenses standard deviation is greater than 0.15 ounces. Okay, so there's my standard deviation for population. That's why the symbols are different. This is sample. This is for you're making a claim about the population, okay, of all vending machine, coffee vending machine. So this is just your little test. This is making a claim about all of them. So that's why the symbols are different, population versus sample. So that's the claim. It's a right tail test. Opposite is equality. So that's our HO. And so now we're going to use something different called variance stats, okay? Because we're testing variance, which is the square. Variance is this number squared. All this has to be squared. This has to be squared, okay? So standard deviation is the square root of variance. So because our test is in variance, not in standard deviation, we have to square stuff. So we're going to do that, get to one sample with summary, and then enter the squared numbers. So when it asks you for sample variance, which was right here, 0.17, we have to square it first, and that gives us 0.0289. This is what you're going to type into StatCrunch, okay? And then HO, you're going to notice a little power of 2, which means that we're looking at variance. So take your 0.15 and square it, and you get 0.0225, and that's what you need to type in to StatCrunch. Okay, once you click compute, you're going to get the chi-squared statistic is 33.396 if they ask you for that. If they just need a p-value or they're testing the hypothesis, you're just going to use this one here. So it gave us 0.1509. Please forgive my mistakes here. I tried to white it out and it didn't come out very well. So again, just p-value equals 0.1509. Ignore the other symbols there. And because this is greater than 0.05, we fail to reject HO, which means that there is not sufficient evidence to support what claim. If we don't have enough evidence to support this claim, we have to basically go back to status quo, okay? That the standard deviation is 0.15, okay? Now, one last thing before we go, and that is you are going to get a conceptual question based on page 387, okay? So just have this ready and open when you take the test so you can refer back to it when needed, okay? Guys, I hope hope this was helpful. If not, please email me and let me clarify whatever needs to be clarified so you can do well on this test. Like I said, I want to do a live meeting next week for the next test, all right, and for the review for the final. So it's going to be interesting testing that system out. I'm looking forward to it, and I hope you can make it. But I hope you do well on this test, and please email me and let me know if you have any issues at all. So take care. God bless. See you soon.